I want to take a couple of minutes to summarize what the lab was about and what you're going to be tested on. We have two columns of data here. One is strands, one is marbles. In graphing, we always make sure the left-hand column right here is the independent variable, and we always make sure that the right-hand column is the dependent variable. In short, the independent variable is the one that we vary and we know what it is at all times. And the right-hand column, the dependent variable, is the one that we're trying to find out. We're not sure what it is, and it depends on the value of the independent variable. We always plot these and we get a graph. Just like this. Things you must label on your graph. The title, number of marbles versus number of strands. Always label the independent variable on the x-axis right here. Always label the dependent variable on the y-axis here. Those are things that we absolutely have to do. Now, not only do we graph our data, we must always come up with an equation. And the equation we get from a line like this, it is in the form y equals mx plus b, but we never write it that way. So when I actually use the formula for y2 minus y1 over x2 minus x1, say for these 2 points at 2 and 3, and I calculate the intercept, the formula that I get for the line is m equals 12s plus 2, where I name my variable m marbles after my dependent variable, and s, the independent variable, the horizontal variable, after strands. But that's not the only work I must do in physics. I must also make sure that I label what each variable is and what the units are. So for my y variable, m is number of marbles, the units are marbles. S, number of spaghetti strands, the units are strands. The slope always has units of the rise variable, marbles, over the run variable, strands, and that's marbles per strand. And finally, our y-intercept always has units of the dependent variable, in this case, marbles. We must always ask, what does the slope mean? In this case, in our lab, what we realized is the slope is each time I add a strand, I need 12 more marbles to break the bridge, which is great. Now, the last thing, what does the intercept mean? What the intercept means, what the y-intercept means in this case is, and I'll tell you, in general, the y-intercept means an initial or baseline number of marbles. So that's the first part of what the lab was about. So we have 5 basic definitions. I had you define them in the lab, and I want to give you versions that are useful for the test, that are more general than just the spaghetti lab. So first we have the independent variable. That's the one that we change, and we always know what it is. That's why the strands of spaghetti was the independent variable. We always knew what it was, and we were the ones that manipulated it. Then the dependent variable is the one that we're trying to find out, and it depends on the independent variable. That's why the marbles were the dependent. We didn't know what the final answer was going to be, but it depended on the number of strands that we had. Control variables are variables that we leave the same so that they don't end up affecting our experiment. They're usually things we don't care about in the experiment, so we keep them constant so they don't change stuff. Example, length of spaghetti or the mass of the marbles are good examples in this particular experiment. Then we have the physical model. The physical model is the words we use, is the word description of the math model that explains. So basically, it's the description of the math model. I'm going to write that a little bit better. It's the description of the math model that explains if the math model is linear, or it's a power, or it's exponential. And finally, we have the math model. That's the equation that we get from the data and the graph that explains what we're studying. It's the equation that lets us say, aha, this is what is going on. So that's a summary of what we've done so far. I hope this is helpful, and we'll be taking this up next week.